The last thing we have to cover is volume of a composite figure. This is going to be super easy, especially when you compare it to surface area. We remember that volume is inside, and so when we did surface area of the composite figure, it was the sum of all the faces on the outside of the two figures, and you had to worry about the fact that two of the faces were touching, not with volume. Because volume is the sum of the volume of all figures, all we have to do is figure out the volumes for each figure separately, and then we combine them through addition. So for triangular prism, remember that, or when we're dealing with this in general, we're dealing with area of the base times the height in both of these cases. For the triangular prism, it's a triangle, so area of the base is base times height divided by 2, and we're multiplying by the height of the whole prism. For rectangular prism, we're dealing with length of the base times width of the base times height of the whole prism. Now all we have to do is plug in our numbers. For the triangular prism, the base and height of the triangle are going to be, base is 18, times the height of the triangle, which is 12, divided by 2. If you need to see it, here's the triangle. So that's how we knew base and height was 18 and 12. Again, if 18 is along the bottom, that tells us that that side is also 18. And then 12 we know is going to be 12. And then to figure out the height of the prism, we're saying what side connects the two sides. And in our case, the height of the prism is going to be 22, so we multiply by 22. And this gives us a total volume of 2,376 meters squared. Now for the rectangular prism, the dimensions are 20 by 18 by 22, which gives us a total volume of 7,920 meters squared. And when we combine those, we end up with a volume total of 10,296 meters cubed. Those should be meters cubed, not squared. Sorry, guys. The last page of this book deals with volume of a composite figure. Here's another one, except this time we're dealing with a square, pyramid, and a cube. Now we know both of them deal with big B, because it's area of the base, times the height of the figure. But the thing to remember is that with the square pyramid, the base is a square, so we know length of the base times width of the base. We know we're going to multiply by the height of the pyramid. However, remember that a pyramid is 1/3 of a prism, so we have to make sure we divide by 3. When we plug in our numbers, please note that there are two heights. It is important that you are able to know which height to use. So when we go through this, we know the length of the base is 20 times the width of the base is 20. There's our base, 20 by 20, times the height of the pyramid is going to be the 9 meters, not the 13. The 13 represents the slant height, because that's the height of the slanted side. That's not the height of the entire figure. So there's an important difference there. We go through and we do 20 times 20 times 9 divided by 3, and that gives us 1,200 meters cubed. For the cube, that's super easy because we know that we're dealing with length times width times height. Or you could think of it, length times width times height, or you can think of it as side to the 3rd power because it's a cube. Either way doesn't make a difference. So we have 20 times 20 times 20, or we have 20 to the third power, however you want to think of it, and that gives us 8,000 meters squared. So to calculate the total volume, meaning how much space is inside that figure, we have the bottom part, which is the cube, and the top part, which is the pyramid. We combine those volumes and we get 9,200 meters cubed.